Hello! In this episode of Finno-Ugric machining, it's not going to be machining. Yeah. We are going to talk about audio. It's a video. Why is audio about any importance? Well, a bad audio can make the whole video really bad. It doesn't matter how good your material otherwise is, but if your audio is bad, then your video is doomed. Yes, really so. So, I'm going to go through today recording your audio, how to do that, and then post-processing your audio, and maybe finally how to attach your this audio into your video. Well, yeah, it's audio. Okay, let's start with the audio equipment. Okay, audio equipment. That's you can spend a lot of money and effort into your audio equipment. Yeah. I try to keep this to the minimum in a way. Well, the absolute minimum is to use the audio your video recording device provides. You might be filming this with your phone, for example. Well, the audio in those is usually optimized for speech, because what you are doing some vlogging with those, and then it's all right. But if you are filming like machining, for example, that might not work as well. There are certain things in a workshop like this, where I'm filming this, where the machines, the dynamics of the sounds are really too much for a phone, and then the audio spectrum is a little bit mildly said, strange. There are also some really disturbing sounds in a workshop like this, like electric humming, and then we have very loud machines, quite silent machines which have a pleasant sound, machines that have a horrific sound. Everything is available. So, you can survive with your phone only, but there are certain things about that camera I'm looking at, and which you are looking this direction. I usually don't use the audio from my camera. This is one example as well. Well, I will switch this on. So there is one thing that actually is really annoying in this. Let's switch this on like this. Well, now you can hear the audio from my this camera, and it's it sounds like to be good at start, but wait a minute. Let's make a little bit of a silence here. Yeah, the background noise started to rise up. This has a compression. It compresses the sound, and the net effect is that it's really disturbing when you are doing something like screwing, and then the background noise starts to climb up. Yeah, and you cannot switch it off in this camera. Okay. Another thing is that if you this has now the autofocus on. And if I move it around, listen carefully what happens here. It makes horrific sounds in the background. The mechanism, the lens mechanism makes sounds which are really disturbing. Well, your camera might do that as well. So it's not good for me. Well, it all depends. Okay, let's switch this off. And then, let's show you the camera I'm at the moment. Let's turn it on again. Oh yeah, now it turned on. And switch it on. And then that is the camera I'm using here now. And it's just a normal SLR camera, yeah. And that camera has a little bit better sound. Now I will switch off to the sound of that camera. Yeah, the background noise doesn't come up. This is because this camera is able to disable this compression, which is really good. Well, but also this one has, as you can hear now, if I move here, so it needs to focus on me. You can hear the clicking sound in the background. It's the focusing mechanism which is creating sounds. Well, therefore, for these reasons, I have a separate audio recording equipment which I will present you next. Well, this here is my Tascam DR40 linear PCM recorder. It can record 4 channels, 1 stereo and 2 separate channels, so actually 3 audio channels altogether. Well, I'm using all of those. First of all, these microphones here, they pick up the general sound from my workshop. I will show you soon what they will do. And the second one is this cable here that is going all the way up in the roof and goes, and then we have a dangling microphone here. Okay, like that. And the final thing is, I have here is a ferrite ring for radio interference suppression, and then we have a wireless microphone, and then I have on my chest this little animal here. Where is it? Here. Here is the little animal. So this is used to pick up my my speech. It's optimized for speech. Well, this darn thing made a radio interference which was causing me some trouble. I will show you how I dealt with it later on, but I also, there is a ferrite rod inside this part here, and also this ferrite ring, which altogether they suppress the radio interference as much as it is now possible here, but you have to post-process the rest away. It was actually quite easy to do. Okay. Well, that is about the equipment, and now let's see what kind of sounds do we get with those. First, let's use only these microphones here. So when I go here and talk, you can probably hear that it's well, a little bit different. Yeah, it is. And I use these microphones to pick up the general environmental sounds here. Okay. Well, then we have this which is in the ceiling. So let's switch that on, like that. This is also picking up, well, the sounds of my workshop. It's very general. The sound pressure is equal, almost equal to every place here. The only thing about that microphone is that it's a vocal microphone, and you should keep it very near your mouth, and therefore, well, it produces a little bit different sound. And last but not least, let's switch on to this wireless microphone, the lavalier microphone, and now you can hear it. It's well, the sound is like this, and this is, of course, it doesn't change when I go to here. Nothing happens, it doesn't change. It's irrelevant where I'm here in my workshop. The sound is always the same. And yeah, so, well, I will now show you some examples of, let's say, demanding sound, and one of those is my dear milling machine. And yeah, especially when you are running it on high gear, this milling machine produces sounds that are really horrific. Let's switch this on. And let's see that it's on high gear. Yeah, it's on high gear. You could hear the VFDs start. This machine has 3 VFDs inside. Okay, let's switch this on now. Well, as you can hear, it's very loud. And it's actually the loudest machine I have here in the workshop, and yeah. And this one, it's not easy to deal with. My lathe and every other equipment is, well, they are okay. Well, next I will go to my workbench and show you some how to deal with background noise. Well, this is a sample of background noise. I am going to filter this in my desktop. So first of all, let's be a little bit silent here. Yeah, that was hard. That was actually quite bad. In the background there are 2 distinctive sounds. First, there is the electrical humming from my isolation transformer. The second noise is the radio interference from my wireless microphone. I will now present 2 different methods to get rid of those. I am using this free program, Audacity, to manipulate the soundtrack. The first method is the noise reduction available in this program. First, a portion that should be silent is selected for analysis. Next, the noise reduction tool is used to analyze that portion. Finally, the whole track is selected, and noise reduction is applied to it. Now, let's listen to it. The background noises are still there, so let's do this again. The noise is almost completely gone, which is good. What is not good is what this does to my voice. Just listen. Well, this is a sample of background noise. I am going to, filter this in my desktop. So, first of all, let's be a little bit silent here. Sounded as if I would have an additional tongue in my mouth. This is the downside of this impressive algorithm. It removes noise really effectively, but it also butchers the original sound. Let's undo the noise reduction and listen to the original sound. Sample of background noise. I am going to filter this in my desktop. I don't know which is worse. Luckily, there is a better way of doing this. Let's see from the spectrum plot what we actually have in there. There is a large mountain of electrical humming at 200 Hz. In addition, there are narrow spikes coming from the radio interference. Let's remove that electrical humming using the notch filter. First, the whole soundtrack is selected. Then, the notch filter is applied to 50 Hz. It is also applied to 100, 200 and 400 Hz. This is done to remove all the even harmonics of 50 Hz. Let's listen to what we achieved with this filtering. Definitely no more humming, but the radio interference is still there. In the spectrum, this is visible as 3 high spikes at high end. I will now remove those with a notch filter. The highest spikes are now removed. The rest are so small that they are probably not audible. Let's listen to whether this really removed the radio interference. The radio interference is gone. Now, let's check whether this had an inverse impact on my sound. Well, this is a sample of background noise. I am going to filter this in my desktop. So, first of all, let's be a little bit silent here. Looks like we have a winner here. There is still some hissing going on, but the sound quality is unchanged. The notch filter is very useful on removing background noises that are linear in nature and have some known frequency. Most often it is some sort of an electrical interference. Noise that does not have a specific frequency, like hissing or wind, cannot be removed with this method. Filtering seems to be a lot of work. Actually, there is less work than using the noise reduction tool. These operations can be done in one go using a macro. Making macros is relatively easy, and then they can be assigned to a button, and then one push of a button is all that is required to remove the noise. Okay. Well, now that we have made some noise reduction, two alternative methods. One that can actually remove your noise quite entirely, and one that is not that good on random noise like wind and baby cry and whatever. Yeah, okay. Well, there is yet another thing you can do for background noise. You can try to cover it. Put something on top of it which will hide it. So let's take a few examples of that. Well, at the top is the sound sample with some hissing noise which we are trying to hide. Below that sample there are 8 different audio tracks which we are going to try out. Some of these tracks hide the hissing noise quite well, whilst some are here just for the fun. Let's listen to the noisy audio track first. This is an example of background noise which we are going to camouflage. Camouflage. The first candidate is the sound of heavy rain. This should do pretty well as hissing and rain have very similar sound properties. This is an example of background noise which we are going to camouflage. Camouflage. That was quite good. The next candidate is the sound of a fountain. This is an example of background noise which we are going to camouflage. Camouflage. This also works quite well. Next is the sound of autumn forest. This is an example of background noise which we are going to camouflage. Camouflage. That was also very acceptable. How about being transported? This is an example of background noise which we are going to camouflage. Camouflage. That was not that good, as the sound characteristics are different. Would howling wind do it? This is an example of background noise which we are going to camouflage. Camouflage. The howling wind did very little to hide the hissing noise. Now, let's try out some birds. This is an example of background noise which we are going to camouflage. Camouflage. I don't know. Maybe the birds are just too loud. Now, can horny frogs make any difference? This is an example of background noise which we are going to camouflage. Camouflage. Not a chance. Those are almost irritating. Well, last but not least, the church bells. This is an example of background noise which we are going to camouflage. Camouflage? No, not the bells. The best sounds for hiding background noise are those that share sound characteristics with the noise. Well, that was about hiding your background noise. You really can do amazing things with audio manipulation. Well, the next thing which can cause a lot of trouble is of course no, it's not of course, but it is the synchronization of your video with your audio. If those are out of sync, the results can be really disturbing. So let's go on and see what we can do about that. Here is a video clip we are going to work with. The track on top is the video with the original audio track. The bottom track is the audio from the lavalier microphone. Now, let's observe how it sounds and looks if these are out of sync. This here is an example of an audio that is out of phase. It's not synchronized. And we are going to synchronize this one. That was not too good. Let's move the lavalier audio track so that it coincides with the video audio track and feel the result after the move. This here is an example of an audio that is out of phase. It's not synchronized. And we are going to synchronize this one. That looked and sounded more like it. However, the sound is not precisely synchronized, and strange sound may result if the soundtracks are combined. Let's unmute the video audio track and play them together. This here is an example of an audio that is out of phase. It's not synchronized. And we are going to synchronize this one. The result is visually in sync, but the audio has a strange effect in it. This is because the two audio tracks are not perfectly aligned. Let's align them more accurately and play this again. This here is an example of an audio that is out of phase. It's not synchronized. And we are going to synchronize this one. It is now somewhat good, but there is still something going on in the audio. This is because of the granularity of the video editor. The smallest step the audio track can be moved is one video frame. In this case, this step is 2/100th of a second, which is too long to make the audio tracks mixable. I will now present a more accurate way to align the audio tracks. Here I have opened the two audio tracks in Audacity to align them with the needed accuracy. The upper track comes from camera and the lower track originates from lavalier microphone. Since the upper track is from camera, it's already in sync with the video it was used to film. We need to do something for the lower track, which is definitely not in sync, because it is impossible to start camera and audio recording at the same precise moment. I always start audio recording first and turn video recording on after that. At the very beginning of every video, I clap my hands 3 times. These claps are clearly visible in the audio editor and can be used to align the tracks. When I stop, I first turn off video recording and after that I stop recording audio. This way I can be sure that I have recorded audio for the entire video clip. Let's listen to the camera track first. This here is an example of an audio that is out of phase. It's not synchronized, and we are going to synchronize this one. In order to synchronize the lavalier track with the camera track, I need to remove the delay between starting the audio and video. First, I zoom into the 3 claps at the beginning of the audio tracks. Then I measure the exact time it took for me to start to record the video after starting recording the audio. The exact time can now be seen at the bottom of the audio editor. Then I select the same length from the start of the lavalier track and delete it. Now the tracks start at the same time, but the lavalier track is still longer, so I trim that excess away to make them the same length. Let's listen to them now. I alternate between the 2 tracks to hear the difference. This here is an example of an audio that is out of phase. It's not synchronized, and we are going to synchronize this one. Now the tracks are synchronized with the video and I can save them. For each video clip I have 4 audio tracks. There are camera, floor, lavalier and roof tracks. The usage of these depends on the content of the video clip. Okay, now that we have been talking about things you can do with your audio track. Well, there are certain things that you shouldn't be doing. I will go through the major things that you really can do that really can make your audio track really bad. Well, as you can hear, there is a background noise here, which I first of all try to eliminate, cover and whatever. I try to make this decent video. Actually, that background noise is such that it's very hard to get rid of. Okay. Here we have some examples of an audio clip opened in Audacity. The clip was taken from the camera audio track. Let's listen to the original audio clip first. This is an example of trying to take over a background noise that you cannot take over. Next, an attempt is made to eliminate the background noise entirely using the noise reduction tool. This is an example of trying to take over a background noise that you cannot take over. The background noise was gone, but the voice was badly tainted. If the camera has audio compression, the result can become even worse. Just listen. This is an example of trying to take over a background noise that you audio compression should be switched off if possible. The next sample is manipulated with noise gate. It mutes audio under certain audio level, thus removing background noise. This is an example of trying to take over a background noise that you cannot take over. Well, it felt like something was missing from that one, not just the background noise. In the next example, bass boost was used to create a plus sound. This is an example of trying to take over a background noise that you cannot take over. Well, plus it was, but too much is just too much. In the next sample I used filtering, noise reduction and bass boosting. However, I tried to keep the changes to a reasonable level to not to alter the sound too much. This is an example of trying to take over a background noise that you cannot take over. That was actually quite good. Keeping the manipulation to a reasonable level can enhance the audio instead of tainting it. It is not possible to polish poop unless you are a Mythbuster. The next clip is from the lavalier microphone. It was filtered for electrical humming, very mild bass boosting was applied, and some reverberation was added to create some room around the sound. This is an example of trying to take over a background noise that you cannot take over. That was also quite good, simply because the lavalier microphone is optimized for speech. However, the last clip from camera audio with moderate manipulation was not too bad either. So let's listen to it one more time. This is an example of trying to take over a background noise that you cannot take over. Okay, well, this about concludes this episode of Finno-Ugric Machining, which didn't have any machining in it. So, the conclusion actually here is that even the simplest equipment can benefit from audio manipulation. You should consider doing it in some cases. Sometimes it's not needed. You have such a good quality original audio track that you don't need to do anything about it. Yeah. Okay. Now, well, I really hope that you learned something and hopefully you also enjoyed about this. Yeah, in the next episode of Finno-Ugric Machining there will be machining. Well, till then, bye!